All right, so actually in examples 4 and 5, we are going to be looking at applications of quadratic functions. I think there is an additional example 6 in the ebook if you would like to look that up and see how that works. Okay, but here's our example 4. Using a quadratic function for projectile motion. I think I want to zoom back out here just a little bit. Give me a second. Yeah, that's not just all the way out, but we can read it a little bit better. All right, number 46, it says a firefighter holds a hose 3 meters off the ground and directs a stream of water toward a burning building. The water leaves the hose at an initial speed of 16 meters per second at an angle of 30 degrees. The height of the water can be approximated by h of x equals negative 0.026x squared. And then I think that says plus, yeah, I'm pretty sure that says plus 0.577x plus 3. All right? Where h of x is the height of the water in meters at a point x meters horizontally from the firefighter to the building. Okay, so let me draw just a little picture of what's going on here. Here's the ground. Let's let this be the building that is on fire. Okay, bad times for it. The firefighter is standing over here. Okay, and he has the hose that he's shooting the water out of. He only has one leg. Let me make him have 2 legs so he doesn't fall over. Okay, but he's shooting this water from a height of, let me go ahead and label this as 3 meters, and that's what this has to do with, the 3 over here. Okay, but he's shooting that water and it's going up in the air and then it's coming back down and it's hitting the building at a height of, it's down here in part C it says 6 meters, but for right now it's just hitting the building, okay? What it says is that h of x, let me write it like this, h of x represents the height of the water, where x represents how many feet he is away from the building, right? So, it says, what is the maximum, part A. I was jumping to part B. Part A says, determine the horizontal distance from the firefighter at which the maximum height of the water occurs. Well, the maximum height of the water occurs about right in here. And you know, that is the vertex of this parabolic shape that the water is following, right? Okay? So really, we need to find the vertex. And for part A, we only need to calculate the x-coordinate of the vertex. And that is found by taking negative b over 2a. So, using our h of x model up above, negative b is negative 0.577 divided by 2 times the a value of negative 0.026. All right? So that's going to be negative 0.577 divided by negative 0.052, I believe that is when we multiply. And then the negative over a negative is a positive, and when you take 0.577 divided by 0.052, you get 11.096. Okay, and so they said to round to 1 decimal place, and so 11.1, and the label on that is he's 11.1 meters away from the highest place where the water hits. Okay? This says, what is the maximum height of the water? Okay? So, what we need to do is we need to calculate the height at 11.1 meters. Okay? When x is 11.1, what's the height? Well, it is a negative 0.026 times 11.1 squared plus 0.577 times 11.1 and then plus 3. Okay? When we crunch all of that, let me go to my calculator and take a negative 0.026 times 11.1 squared. All right. This calculator knows to do exponents before you multiply. Okay. And so for the first term there, we're going to get negative 3.20346. Okay. We are then going to add that to the 0.577 times 11 point, whoa, I did too many. There we go. 0.5, oh no. Okay, hold on. I'm a hot mess here. Delete. Cursor over. There we go. Okay, now times 11.1. Okay, and then go ahead and say plus 3. This calculator knows I better do the multiplications before I add everything together. And so that comes out to be, to the nearest decimal place, it is 6.2 meters. Okay. Okay, so that's 6.2 meters is what that height is. So this says the flow of water hits the house on the downward branch of the parabola at a height of 6 meters. They're saying it hits right here at a height of 6 meters. How far is the firefighter from the house? Round to the nearest meter. And so what we want to do here is we actually need to solve kind of an ugly quadratic equation where we know that the height now is going to be the 6 meters. So we actually need to solve 6 equals negative 0.026 x squared plus 0.577 x plus 3. All right. Let me see. First thing we want to do in solving this quadratic equation, get everything on one side equals 0. So we have 0 equals negative 0.026 x squared plus 0.577x, and then 3 minus 6 is a negative 3. Okay, now that we see where this came from, let me scroll a little bit and work on solving this equation. Now, I don't love it when the lead coefficient is a negative. So I'm going to multiply both sides of this equation by a negative 1. Right? We can always do that. We can multiply this side by a negative 1, and we can multiply this side by a negative 1. That's going to let us have a positive lead coefficient of 0.026 x squared. Then I've got minus now 0.577x, and now I've got plus 3. I like that a little bit better. So I'll have a positive A, there's my B, there's my C, when I go to solve my quadratic formula. X is equal to negative 0.577, which is a positive 0.577, plus or minus the square root of negative 0.577 squared. Punch that into your calculator and you get, I'm looking at my notes, 0.33293, 0.33293 minus 4 times the A value of 0.026 times the C value of positive 3, all over 2 times A. Let me go ahead and double that, and that is 0.052. There's 2A. Okay? Now, our two solutions for X, which represent the meters where the height of the water is at 6, okay? is going to be 0.577 plus or minus the square root of something divided by 0.052, okay? When we take 0.33293 minus what will be 0.312 inside there, okay? We end up with 0.02093, okay? That's what that is when we combine actually this number minus this number. That's the 0.02093. All right. This is definitely a calculator kind of thing. All right. So I'm going to do one with the plus and one with the minus. Okay. 0.577 plus the square root of 0.02093. Let's see. 0.577 plus delete. Okay. The square root of 0.02093. All right, that is equal to that. Then I need to divide it by the denominator of 0.052. So we get 13.87. And then I think that's going to be our answer. The other answer of, let me put parentheses here and do the whole thing at once, 0.577 minus the square root of 0.02093. Okay, I'm going to cursor out of that, hit that. Okay, that's the numerator divided by 0.052. That other answer for x of 8.3 is the other meters away that the height is at is 6 meters. Okay, so we've got two answers. One is say to the nearest tenth, round to the nearest tenth. Yeah. Oh, round to the nearest meter, actually. When we round to the nearest meter, we've got 8 meters or 14 meters when we round those. Okay? So we've got 8 meters or 14 meters. And our answer is going to be the 14 meters. Let me show you why I know that is. Okay? So remember, our two choices were 8 or 14. Oh, I went too far. Okay. So the other place where this is at a height of 6 meters is about right in here, and that is the first one, 8 meters. The second one is when it hits the house, because it hits the house on, it said, the downward stream. Where did it say that? It said, maybe it said that down here. Yeah, on the downward branch of the parabola is where it said that. So that's how I know it is the 14 meters. Instead of the upward branch of the parabola would have been the 8. Okay?